Hey everybody, welcome again to Web Tutor Online. It's a Physics 101 series, and I promised we are going to cover energy. So it's a short lecture today, and so let's get right into it. Right, so there's different forms of energy that we're going to study in the process of this course. We're going to look at electrical energy, thermal energy, nuclear energy eventually. Alright, but today we're looking at two types of energy mainly. Kinetic energy, right, where it's the energy of motion, and it's calculated a half by the mass by the velocity of the object or body squared. Right, simple calculation. Of course, all energy units will be in joules, so that's an important formula to remember. Kinetic energy is equal to half mv squared. Right, and the other one we're looking at is potential energy. Potential energy, of course, is stored energy. So kinetic was motion. Potential is stored energy. So the energy basically found in a spring, elastic rubber band, water at the top of a waterfall before it begins to fall is considered to be potential energy. Right? So it has the potential to do work. Right? And potential energy is calculated mass multiplied by gravity. G is gravity, which is acceleration, and then of course by the height. Right? As you can see, as the motion takes place, energy actually is going to convert from, in the case of the kid kicking the ball there, from kinetic energy, and as the ball reaches the highest point of elevation, it actually is going to stop. It's going to become stationary, and at that point of stationary condition, it's going to have a maximum potential energy above the ground. Once it begins moving again, descending towards the ground, the potential energy is going to decrease and the kinetic energy is going to increase. So that brings us to a valuable point, the conservation of energy. So the law simply says energy cannot be created nor destroyed, but it can be changed from one form into the other. Simply put, it just can't disappear, right? So as you saw in the last example, and even in the example I have below here, energy changes from one form to the other. In the case of the pendulum, at the highest point, you're going to have where it becomes stationary above the ground level. It's going to be stored energy. It's going to have the potential to move, and it's going to have maximum potential energy. Once it begins to move, that potential energy now is going to convert into kinetic energy. So you're going to find the potential energy is decreasing while the kinetic energy is increasing. And so energy just doesn't disappear, but it actually converts from one form to the other. And there are other forms that energy can also convert to as well. Right? It's important to know about work, and working physics is not your everyday meaning of work. It's basically when a force moves, work is done. And so work is calculated force by distance moved in the direction of the force. And work requires energy, of course. So the units will be in joules, and its force will be in newtons multiplied by distance in meters. And so you have two people pushing two big, huge concrete balls. One wing, one of the person is pushing with a force of 500 newtons. The other pushing with another force of about 500 newtons. So let's say they're pushing with the same amount of force, both of them. Right? So they're both pushing with 500 newtons of force, but one pushes the ball 10 meters, the other one pushes the ball 6 meters. Is there a difference in the work done? Yes, there is. Based on the calculations, the guy pushing 10 meters is actually going to do more work. The guy pushing 6 meters is actually doing less work. However, which one's using more power? The guy pushing 10 meters is doing it in 10 seconds. The guy pushing 6 meters is doing it in 5 seconds. So then you consider what is power. Now we looked at the lever, we said it was a simple machine. That's now machines or devices that basically do work. And power is the amount of work done in a unit time, or in seconds. So it's how much energy is actually changed in a unit time. And of course the unit of power is the watt, right? That's equivalent to 1 joule per second if we use the formula. And so, depending on how much time taken to do the work, that determines the power. So if you do the work in less time, you use more power. If you do the work in more time, it's actually less power, right? So that determines a lot about the efficiency of your machines, right? So we talked about levers, we talked about simple machines, and machines. You need to determine whether a machine is efficient or not. So the work done on the load divided by the work done by the effort, or simply put, the energy output over the energy input, or the power output over the power input determines the efficiency of any machine. So if I have to put in input of 100 joules, then I get an output of, let's say, 9 joules of light, whereas I lose 91 joules in heat. My output is 9 joules, whereas my input is 100 joules. My efficiency here, 9 over 100 by a percentage by 100 is equal to just 9%, not making it not very efficient, right? Because we're losing most of our energy is being transferred into another form, which is heat, and so the majority of energy is now being transferred into the form that we want it to be, which is light, and so it's not very efficient. Okay, so I hope you enjoyed the lecture today. It's a short lecture, simple lecture, but it's very important nonetheless, so I hope you go through it, revise it, and keep us in the loop. Let us know what's going on with you, if these lectures are helping you at all, and look out for the lectures coming up, because we've got motion coming up next, and that's about 25% of the course so far, so we're going to do some recaps in the not too distant future. Have a good day.